Hello, Jerry. I hope you're doing well still and that everybody in your life is healthy and staying safe. And I don't think I did one of these PowerPoints for you last time, but this is just a nice way to go over your soil reports because you can come back and listen to it a second time and you don't have to wonder if what I was saying, if you remembered it right. You can always go back and listen to it second time. You can give it to a general manager or somebody who doesn't understand your job and let them listen to it to see if they can understand it and get them more on the same page as you are. So I hope this helps, and I know data was all sent in to review what's going on with the HCT products, and this should be a testimonial for the HCT people. The results are fantastic in showing just the changes that I would expect to see. And what makes this important is you being a lower budget club, having the ability to do these things affordably, whereas it wasn't an option for you before. Should be impressive for you. But let's take a look. Oh, forgot to throw that in there. So this is the irrigation sample, irrigation water sample, and it's a little bit dirtier this time. The water's there's more total salts in it. Seasonal changes aren't unusual. Typically, when you're in the peak of your rain season, if you're getting a lot of rain, the water cleans up, the pH drops a little because rainwater is a little more acidic. So you get some dilution from rainwater. Dry times of the year, it tends to get worse. There's a lot of courses that when it does get dry, they have to use supplemental well water or reclaim water, things like that, and mix those waters or whatever. So it can change. It can change a little, but typically if you're using the same water source day in, day out, it doesn't change that much. And a club like yours that has limited resources, we could get in and treat this water and try to change the characteristics of this water and be very effective at it. It would improve the conditions on your golf course, fairways and everything, but when you're limited on your resources, sometimes it's just not a possibility to do it. If you can afford to do it, I'm going to show you the reason why you do on these, why you should on these soil reports. This thing should be a testimonial for the HCT guys because everything they talk about I see here, and that encourages me because initially I'm just taking their opinions and what they're seeing and what they're saying. I mean, I have to trust them that what they say their product's going to do, it does. And with this product, and probably one of the only products on the market we've ever tested that we see significant changes in soil conditions and everything, is from this product. So if we always start with total salts, and I think you were 900, almost 1,000 the last sample we did, and you're about 1,300 total salts now, which is a little above the dead center line when you're talking about cleanliness of water. It's slightly dirty. Sorry about that. Had a phone call. So that is I threw that arrow in, so that's 1,350 total salts in the irrigation water. The number to the right of that, it's 3,600, almost 3,700. That's the total number of pounds of nutrient you're putting out per acre foot of water. So obviously in the dry times of the year, if you're watering every night, you could probably put out those 12 inches of water in a couple of weeks to a month, depending on how much water you throw out. In the rain season, it may take you several months to put that out. That's a pretty big impact of nutrients on your soil, and they accumulate in your soil. So when we're talking balance, we have to look in and we have to decide, are we going to try to balance the water? Are we going to try to balance the soil? Well, again, that goes back to, can you afford to balance the water? So that's a decision you have to make. And your water is of poor enough quality to warrant that you inject wall to wall. Again, it just comes back to, is it affordable? You would benefit greatly in your fairways and your tees. You would mineralize everything that's there. You have a tremendous amount of nutrient in your soil that's just being locked up that could be free fertilizer for you. So those are certain options you have to weigh. If all you can afford to do is continue to do what you're doing and treat your tees, your greens, and then you want to expand into some little areas and spray it, that's fine as well. But these reports are going to show you the improvement in your soil structure and just the balancing of your soil it really is pretty impressive. And it impresses me because I stick my neck out by recommending a product which our company's never really done before. But this is the reason we do it. We see these kind of results in our data, and it's consistent. It's repeatable data, which is, anytime you go to a research professor, they're always going to talk to you about repeatable data. It's got to be repeatable. And we see it repeatable here. So the box I just threw in there, that's the scale on how dirty or how clean your water is, and yours bounces in right there. It's a little on the dirty side. Does that mean that it's of poor quality? No. If it were perfectly balanced, that's just free fertilizer. Where we start worrying and when we start seeing bad quality is when things aren't in balance. And yours is that way. You have really high sodium, you have high chlorides, whether it's from effluent water or it's just because you're so close to the Gulf of Mexico. But for whatever reason, your water's not of very good quality. If I'm giving you a report card on the cleanliness of it, I'm probably giving you a C- on that. And then as far as the quality goes of the water, I'm giving you maybe a C. It's a little dirtier than it is of poor quality. Where did I just point that? Okay, when we look at quality, we look at balance again. So we come down to the anions and cations. And sorry, I didn't get that box aligned real well down on the bottom right. But you're pretty well balanced between your cations and anions. So when we look at that, what was it, 3,700 pounds? Let's say it's 4,000 pounds of nutrients. It just makes it easier to explain. Then half of them, say 2,000, would be cations and 2,000 would be anions. So you got a good balance of cations and anions, and that's a good thing. But then we have to look at what those anions and cations are. And there is that. I get ahead of myself sometimes. So I threw a box around your major cations, and you can see you're 57%, almost 60% sodium. Well, we want that to be 10%. So you're 6 times higher. So that alone, that one factor, shows that you have poor quality water. And I was looking at that, and I didn't have my glasses on, and I thought it was 37%. So that C rating I just gave you, now I'm giving you a D. So anyway, but what do? We try to compensate for it in the soil, and you do it with your management practices. You've done a good job for years. I mean, you look at it and people talk about putting in paspalum because it's salt tolerant. Well, Bermuda grass is very salt tolerant too. To have those levels of sodium in your irrigation water and to still have good turf, that takes a little bit of magic, and that magic comes from you and your programs and the way you're managing the sodium and the way you're managing the structure of the soil. So we look at, going back, we look at the calcium. You're 26%, and we want that to be about 55%. So where that sodium is occupying space, it's taking up space for calcium. Your magnesium should be 20%, it's 15. Your Potassium, we like to see that 10% or higher. So you can see the sodium's affecting everything there. We look at your major anions, and you're not tremendously out of balance there. Your anions are actually a little more in balance than your cations are. Ideally, we'd like to see that a 1:1:1 ratio. You're a little lower in bicarbs and you're higher in chlorides. Chlorides are very soluble though, and they do make nutrients soluble. Yes, it causes issues with respiration and transpiration in the plant, and things transporting into the plant and out of the plant. None of those three anions are good if they're in excess. I worry less about bicarbonates being in excess, even though they'll form some scale and stuff, but at least they're not destroying soil structure. SO4 can destroy soil structure if it gets high. Chlorides can just really have a negative impact on the plant. It doesn't so much have a serious impact on the soil as much as it does on the plant. So ideally, again, that would be 33, 33, 33. But when it comes to irrigation water, you're basically living with what you got. We look at that box, and that shows you how much nutrient you're putting out per 12 inches of water. And you look, say, for example, at your sulfur, your 334 pounds of sulfur. That's very high. And so that also shows some poor quality of irrigation water. That adds to it, because when we get high sulfur, high sulfates, we get high counts of anaerobic bacteria. Now, the anaerobic bacteria in your irrigation water is 10 to the third power, which is slightly high, more towards a moderate side. So you don't have a lot of anaerobic bacteria in the water, but you do have a lot of it in the soil. So it's something that we have to pay attention to. So, but you look at that, and you look at your calcium, almost 300 pounds. That's a good amount of calcium going into your soil. But if you were to try to match that with a granular application, you'd have to put out about 10 times the amount. So it just shows you how much those nutrients are impacting the soil that are in your irrigation water. Your sodium absorption ratio is very high. It's 9.09. We like to see it under 2. That means that the sodium is affecting every nutrient in the water and is going to impact every nutrient in the soil. When we look at the adjusted sodium absorption ratio, that is how is the sodium affecting just calcium and magnesium. And the reason that's important is because if you have that sodium really high to calcium and magnesium, then you're forming scale in your soil, which can plug your soils up. It can plug up drainage. It can cause problems in your sprinkler heads clogging up. A lot of issues can come from that. And the rule of thumb from the USGA to see if your water needs to be treated with a chemical acid is if the adjusted is 2 units higher than the SAR, which you are. You are 2.5 units higher. So it's telling you your water could use some treatment. And there's your anaerobic bacteria. So now here's where the rubber meets the road, and we're looking directly at the applications you've been spraying on your greens. And when we look at the significance of what we're looking at here, we look at the soil structure. And you can see that over a 6-month period, your organic matter has come down. Now, it does tend to do that this time of year because you're doing your cultural practices, your aerifications and stuff, and you're kind of at the end of your season. So we would expect, sorry about that, I got all choked up. We would expect that to be lower normally. But the saturation index being that much lower, we typically don't expect that through a season. We don't expect that much of a movement. So you have much more oxygen in your soil. you're in the ideal range at 50% before, we're waving red flags saying you got to get oxygen in the ground, you got anaerobic bacteria, you got other things causing that. And now you're clean. It's cleaned up. You're 42%. I'd like to see it about 38%. So, keep going with doing what you're doing and get it down there some. But it just shows such a tremendous improvement in the amount of oxygen in your soil. When we look at the CEC, it's gone up. And your organic has gone down. And typically CEC is a number they walk into. It's not something that shows up, and what they do is they extract everything and then they measure the number of nutrients in the soil. That's all CEC is. And because you have more than you have last time, it's showing me mineralization of what was in your soil reserve. The weaker acids they use to do that stripping of those nutrients are just going to try to mimic what's going on in nature. And so in nature, we already know that, your CEC, as old as your greens are, should be around 8. Because it raised up like that, you've got a lot more mineral that is being mineralized. You got a lot more nutrients that are being mineralized, and that's why it's measuring higher. There's more nutrient there for the plant to consume. When we're looking at these type things, now you're gonna, we've got guys that have 30 of these data points. They've been with us for 15 years, and then this data becomes even more important. You start comparing to averages, and things will average out. But we look at these ratios more than we look at the numbers, because the fact that your CEC is 10 and it was 8 before, you're going to have more nutrient. So if we look at all those nutrient loads in there, there's more nutrient there. But when we look at the percentages down below, they're actually a little bit lower. So that shows that the calcium, the excess calcium, is being mined. Your ratios are better. Now, your ratio of calcium to sodium has come up, which is good. You're mineralizing more calcium to get it in there to fight that sodium. Ideally, we want that 35 to 1, but it's a big improvement over 13 to 1. And then you look at your potassium to calcium. It was really high before. It's a little bit lower now, and you can see the balance coming. So very encouraging to see those kind of things. This is soil solution, same thing for the 2 sets of samples from spring to fall. We look at your anions, and they're a little more imbalanced. Look at your SO4, it's coming down. You had a lot of anaerobic bacteria, and if you remember correctly, in the irrigation water, the SO4 is lower than the bicarbs, and you had so much more SO4 than bicarbs. It shows that you were having physical problems to get that over into solution. You're getting more balanced, and that is a direct effect on using that acid product. Things are starting to mineralize and balance. Your soils are starting to get unplugged and cleaned out, and your anaerobic bacteria counts are going down. We look at your major cations. Your sodium's down, so it's mineralizing, it's leaching through, it's becoming inert with the products you're using, so it's dropping. We expect to see it continue to drop. If you remember, in the irrigation water, again, you were 60% sodium. You're 20% less here. And it should be 60% because that's what's impacting. And even more if you got heavy winds coming off the Gulf of Mexico. I know you took on a tropical storm this year, so your sodium in theory should be going up, and it's going down. So again, nothing but good. Okay, let's take a look at the individual soil report. And again, we start with soil structure. It's much better. The pH is high now, but again, I don't worry about high pH because the plant makes an adjustment on its own. The plant grew itself for billions of years before man came along and decided to start cutting it and harvesting it on a daily basis, and having people trample on it and play games on it, and it did a good job of keeping itself alive. And that's a natural adjustment it makes in the pH around the root zone, where it'll either secrete an acid or a base to adjust the pH, and it's adjusting it for nutrient uptake. And when you read all those articles about it, they lead you to believe that the plant has an ideal pH and it'll just adjust to that. I believe it goes much farther. I think that if the plant's deficient in potassium, that potassium has an ideal pH for uptake, and the plant will adjust down or up to that ideal pH for potassium, and it'll pull it in. And let's say it's deficient in calcium. The pH of that may be 7, the ideal pH. So if it's deficient in calcium, I believe the plant adjusts to try to take in calcium. So it even goes beyond that. So never worry about pH unless it's in the 8s or the mid 8s, or if it's down around 5, then we start worrying about pH and we try to make some adjustments and corrections. But other than that, the plant can compensate for it. If the pH is 8.5, it's going to have a hard time secreting enough acid to get it down to the level it wants. Or if it's at 5, secreting a base to raise it up. So, but when you're in the range you're in, it's not a concern. So I'll always point at phosphorus just because it is an EPA hot button, and you have to prove a need to, as far as the EPA is concerned, you have to prove a need to use phosphorus and nitrates, and you can't prove either on this report. You can't prove that your nitrogen or your nitrates are in the optimum range and your potassium is high both in soil reserve and soil solution. So the EPA is saying don't use it. That's why we do the tissue testing. You've done a few of those. And if you do apply phosphorus, I'm sure in your plant tissue it's showing that phosphorus is low. And if that's the case, then make sure you attach that tissue test to your application records. In case the EPA ever comes in, they can go back 20 years in your records and look, and they can fine you for that. If they say, okay, you can't prove a need to put this phosphorus out, we're going to fine you and your club $1,000 because you did that. So make sure you cover your butt with when you're using nitrates or phosphorus. If the plant tissue comes back and says it's adequate in the plant tissue, then don't use it, because the bottom line is you don't need it. But I find it really hard to believe that in the summertime that you could keep it enough phosphorus in the plant to show that it was in the optimum range on a plant tissue test. The plant's just using too much energy in the summer, and phosphorus is responsible for that energy. So we look at your potassium, very, very low. We look at your, I don't know if I'm pointing at magnesium or calcium. Your magnesium's good. I must have been pointing at calcium. Your calcium's high. And so most agronomists are going to look at that and say, well, your calcium's really high. You don't need to use any calcium, but they're not taking into account your high sodium levels. I put that box around the base saturation, and remember, that's the base saturation that was developed in the 1950s in Nebraska cornfields. And when you think about corn, where's its natural environment? It's in the Midwest. So that corn had been growing there for many millions of years, and so it's the ideal optimum environment. So are these target ranges perfect for turf? There's no way. They're perfect for corn in Nebraska, whose fields are plowed twice a year, and they have plenty of oxygen because of it. So what we did was take it a step farther and create this, which are exact nutrient levels. Instead of a range, we go after a number, and we did it with 15 years worth of data. It took us 6 months to enter all the data into a program, and then we took the lower 15% and the upper 15% and removed them and came up with an average. and we came up with ideal ratios. Now, yes, calcium's high to potassium, it's high to magnesium, but because it's low to sodium, you still need to be using the calcium in your granular applications when you aerify. Right now with your anion situation, it's telling you to keep using the dolomitic or just straight calcitic lime. Your magnesium is still a little bit low in ratio to calcium, so I would use the dolomite and keep doing that because that number's coming up. If it gets to 35-1 and the others are high, then I'm going to be telling you don't use anymore. So you're approaching that. You've made progress. You should be tickled to death with the progress on this report. I point that arrow at that. This is a screenshot, so you can't hit on those tabs, but the files that Charles sent you with all these individual samples, you have all these tabs at the bottom. And if, for example, it says low and your potassium's low, so you go down to those tabs and you see the one that says K low, you punch on it, it's going to tell you what source of products to use, why you're using that product, why you're not using another product, and a lot of information on managing potassium in your soil. Now, when you look at the one, for example, the one that just says nitrogen, that's just an article on nitrogen and the general how do you manage nitrogen on a golf course or in a farm or anywhere. Just how do you use and manage nitrogen and things like that. And those are just educational tabs. Not so much for you, Jerry. You've been doing this so long, you know what nitrogen does in a plant and what it's there for. But doesn't mean you're GM or some curious golfer or an assistant or somebody who wants to learn the trade doesn't need to know. So you can use those and print out reports, and you can even share this PowerPoint with people so that they can understand what we're seeing and what you're seeing and what your job entails. It's not just going out and mowing grass and watering, and it should be easy to grow grass. All you got to do is plant the seed and water it, right? Yeah, well, not when you're harvesting on a daily basis and cutting the turf as low as you cut it. So we are looking for precision. That's why we came up with that precise box on that left-hand side. And then I'm just pointing at the higher levels of calcium, and then boom, you're low with sodium, so keep using it. Now, we're over on the right-hand side, which is soil solution, which is what is available to the plant. And if you remember on that multiple sample where we saw what you did before, there's a much better balance of your anions to cations. Let me come back to that in a second. And those are your cations. There's been improvement there. We still want to knock sodium out. Your magnesium's at a good level. Your potassium's only slightly low compared to how low it is in soil reserve. So that shows you're mineralizing some of that potassium that's in there and getting it in solution, or your applications that you're doing, the products you're using are helping to raise it. But if we knock that sodium down, what's going to come up? The calcium most likely is going to come up. So need to keep working on that, doing the same things you're doing, flushing, trying to overwhelm the sodium with calcium, the use of the acid, which is going to make it more soluble, make it leach quicker. It's going to make some of it inert to where it's not even registering in the plant. The plant can't take it up. And it's not occupying any space on the soil colloid. So we're seeing good things there. That ratio shows calcium to sodium in solution. We want it at 5-1. So that's why you need to keep using the solucals, verticals, tricals, whatever it is, those very finely ground calcium products in a soil spray. And keep using those. That's going to help with the management of the soil, the sodium in the soil. So if you're not currently using those, get a hold of me and we can talk about which one of those would be most efficient for you. Your nitrate to ammonia ratio is much better. Before it was I think you were much higher in ammonia, which meant that the metabolic functions inside the plant weren't being as efficient as they should be. So it's more efficient. The plant's more efficient. And that's a very good ratio. So when you are using nitrogen and you're spraying it on, keep using your nitrate. Right now, I would be using either potassium or calcium nitrate at low rates. You're talking, 10, 12 pounds per acre at the most in a soil spray of one of those two products or both of those products. We did the physical test, the textural test with the tubes you sent, and if you look, you do have a lot of silt and clay in there, a lot more than we'd like to see. But the age of those greens, it's not unusual. You still have, what's that, 73% of the coarse fines and medium sands in there. So you still got plenty of that at the top. But if we never really want to change our top dressing because then you start getting layers. But we might want to discuss what you're using for top dressing, and we might want to go with a little coarser sand. Whatever the organic content in there, we want to try to keep it the same, but maybe need to start looking for a coarser sand so we can start improving that number. That's just going to help with your water infiltration, the oxygen in the soil. It's just going to help you. And you can do that with inorganic amendments too, but I don't really see with an inorganic amendment where you need to be holding more nutrient. You already got a really good holding capacity. Typically, those amendments are used on new greens that can't hold any nutrients. They'll put those in there so it gives you more negative charges on the colloid or around the soil colloids that can hold on to nutrients. I don't see where you need to hold nutrients. I just can see a little bit of where you need to flocculate the soil a little bit more with some more coarser materials. And I do believe that's it on this. And oh, no, got two more boxes. And there's your irrigation water compared to what you got in solution. And you can see your bicarbs are a little bit higher. Your sulfates are higher, but they are much lower than they were the last time. The last time I think they were 50-60%. Your chlorides are coming, well, your chlorides are down, but you see a more of a 1-to-1-to-1 balance there. So that's a good thing. When we look at your cations, much improvement on the sodium, calcium we need to come up with, magnesium needs to come up, potassium needs to come up. So keep doing your granular applications with calcium, potassium, magnesium. Still stay away from the sulfates. Look for either organic sources. Look for like nitrate sources for your potassium, magnesium. You can use potassium humates. If you can find a magnesium humate, they're very hard to find, but if you have a supplier that has some, things like that, try to stay away from the sulfate for your nutrients until we can get that number down a little bit more. You're getting in a better range. When we get that down, we want to see it just a little bit below what it is in the irrigation water. You're not quite there yet. So, and I do believe that's it. If it is, then you have a great day. Give me a call. I'm sure you will when you see this and you have some questions. Give me a call and we can talk about it a little more in depth. Thank you, Jerry, and you have a great day.